Okay, so today we are going to talk about web architecture and this kind of stuff. And of course, you should already know it, okay? Because these things are always updated in advance in the course schedule, okay? So today, that's Thursday, right? So these are the two lectures. Tomorrow we will have still two groups for the lab. So we will run until 7 p.m. And we will see how it works. I mean, we already saw 1 week. Let's try a second one, and then we'll take a decision. Maybe we only have 2 groups. And I can try to ask if maybe, the schedule can be rearranged so that, the second group is not so badly placed in the week, okay? But, I mean, I cannot promise anything because, I mean, they don't hear anybody when asking, for changes in the schedule. Because, I mean, it's so difficult to have things not at the same time of other courses and free rooms and so on, okay? Anyway, so for this week, that's the schedule. So tomorrow still 2 groups. No activity on Monday, okay? So there will be no lectures, nobody in the room. Okay, I will delete it from the calendar as well soon. I mean tomorrow, I think. That's just because we are running, quite fast for the lectures. I think now it's time to take a break for one week for 1 lecture. Okay, and then I'm not sure, maybe it will happen again, but towards the end of the course, okay? That's because you need to keep up with the labs. I mean, it's useless that we explain a lot of things and then you can experiment things in the lab, okay? So the lab in next week will be about what we are going to explain this today, okay? And then we will go into more details about that, and you will be able to experiment it in the next lab in the week after. Okay? Okay, so just please remember that Monday there's no lecture, no activity. Okay? Just for next week. Okay. And if in doubt, just check the official schedule. Okay? Or ask on Telegram. Okay? I mean, it's public information, so there should be no doubt, but in case, I mean, we can try to use this Telegram channel that we have, okay? Okay, so if there are no questions about the past things that we saw during lectures, so basically about JavaScript, of course, you are always welcome to ask things during the lab, no problem about anything, okay? Past and future as well if we know. Okay, I mean, depending on what we are going to do this year, of course, we know what we did last year, for instance, and we can give explanation about that. If not, so we can start discussing another important topic in this course, which is about how web applications are structured. And so first, we will recap a little bit of concepts from networking and how web works and so on. So most of these concepts should be already at least partially known to you, okay? But of course, we will soon introduce something new, specific for this course. I mean, how to interact with the web server, especially for requesting information, not just pages, which is the old way in which applications were designed. I mean, requesting information, the data that need to be shown, and the data that you need to store on the server, and et cetera, that we are going to see today. Okay, so all the topics that we are going to mention here in a sort of overview, they will be discussed in more details in the next lecture. So we will talk about the server, and that's the first part we are going to address in the course. And then, of course, we will spend a lot of time on the client part, where we need to design the interface of the application, where we will use React, etc., the framework that we mentioned in the beginning of the course. So this is the overview of the system. We have a front end and the back end. So the front end is basically your computer. It can be the computer, actually a laptop, fixed PC, or a smartphone, whatever computer, I mean, in a very broad term, you have in your hands. okay? And there is a software that is running to make the web application work, and that is basically the browser, okay? There's a browser, I mean, Firefox, Chrome, and this Safari, whatever, that runs inside the computer that you have in your hands. And there are a lot of technologies involved. We will discuss them later. And this device, this computer, communicates to another computer somewhere in the network. That is the server that we call here in generic terms backend. And it communicates through the network, okay? And the network, regardless of the way in which data is transferred, I mean, wireless, wired, local network, a wide area network, whatever, I mean, it allows us to carry packets which are filled in with bytes according to a specific protocol, okay? That will be the HTTP protocol, that is the basic protocol used for web, and we will discuss it later, okay? So once we arrive at the server side, this data coming from the client, I mean coming from the front end and going back to the front end will be processed, okay, by a program that runs on the server side, so on this backend. And on this backend, we will have also a way to store information permanently in the database, okay? And as I already said in this course, we're going to use this SQLite database just for convenience, but can be any kind of database. Database system is basically a way to permanently store information in a computer in a way that can be easily accessed, retrieved, and so on, okay? Okay, that's the overview. Of course, don't forget about the user. The user is interacting just with this part, so with the user interface. Okay, that's why it's called user interface. Okay, so basically with the screen, and it has an input device, can be your finger that touches, the screen, or can be the mouse or pointer or something that helps you to perform actions in this interface. Okay. Okay, so the first one, as we said, it's the browser. Chrome, Firefox, and so on. Those are the major browsers, and there are quite a number of technologies involved in terms of languages with specific purposes, like HTML for description of the page, CSS for styling. Of course, we already saw JavaScript. That's for programming, okay, and that's a more difficult one. That's why we started from there. And other peculiar things that are internal to the browser that we will learn how to use it, how to use them later. Then we have the network, and there's a protocol, and the basic protocol that every web application nowadays uses is HTTP, also because it's basically the only supported protocol by anybody offering you access to the network. Actually, there's an underlying protocol which is TCP, but over that, typically we speak HTTP with the remote computer, the server, the backend, okay? And so we need to recap how it works. I mean, you should already be familiar with HTTP. It's not that difficult, especially the older versions. And we will have also a format to transmit information, application level information, that is this JSON that we're going to see later, I think today. Yeah. That basically allows us to encode information in a way which can be easily parsed, so understood by both the backend and the frontend, so the browser and the server. And then we will have the web server. Okay, we'll talk about this in a minute. Okay, so let's go back. HTTP protocol. HTTP protocol is very simple. I mean, the older version, 1.1, is basically a text-based protocol. So we can open a network analyzer and read the exchange. I mean, it's really in text, TXT. So we can read it. And it works as a request-response protocol. So there's nothing coming back from the server unless we ask for something, okay? We need to ask for something, and then we will get an answer in reply to this request, okay? So this is an HTTP request. Just an example, I mean, we don't really care about all these fields. I mean, the important thing is here in bold, the URL and the host to which we send the request, okay? We will go into more details in a minute. And then an HTTP response, where the server says something about how the request was fulfilled. I mean, everything was fine, okay, or wasn't found, or whatever problem arose on the server, okay? There are quite a number of fields again, and then there can be a content, okay? In the typical case where we just ask for content, get, and there's a content, okay? That we call body in terms of HTTP. This is all specified, I mean, it's in RFCs and documents like this. So the response can vary quite a lot depending on what we asked and what the server was programmed to do, okay? Can also be empty. I mean, if there's an error, there's nothing to answer. I mean, I couldn't find the information, so I mean, the body is empty. Or can be static content, like we retrieve files when you download a file and stuff like that. I mean, it's just static content on the server, and we ask to transfer the content, and it will be sent back in the body, okay? The HTTP, remember that it also supports binary types, binary transfers. I mean, you can transfer any kind of information without restrictions. And can also be dynamically generated on the fly by the server, okay? That's the typical case of traditional web application. With traditional, I mean older web application. Nowadays, most of the application will follow the pattern that we're going to explain in this course, okay? So, it can be content to be shown with a special language used to describe it, like HTML, or more often, and as it will happen in our course, JSON data, so this format specifically for transferring information. HTTP doesn't care about the meaning of the payload. We just need to say, you know, which format was used to encode the payload. That means the body. Also for when you are requesting things and when you are answering back things. And I mean, and the point is, we can just transfer any kind of format. Okay. Okay, we'll see this later in a more detailed example. Okay. So the client typically initiates a request, a transaction, as we call it here more formally. So you do an action in the client that tells the browser to perform a request towards a remote computer, the server. Okay? And so basically the browser encodes an HTTP request. So the browser is able to speak the HTTP protocol and can put something into the body of the request if needed. It will arrive on the server. The server will interpret the request, and if needed, it will perform some operations, depending eventually on some parameters that we send to, together with the request and so on. And it will answer with something that needs to be sent back to the client that initiated the request, which typically tells the browser to show something in the interface. Okay. In the older days, when first web application, I mean the web in general and web application were designed. I mean the server answered directly with content that could be directly displayed by the server. So it answered with some HTML content. Okay, HTML is the language that can be used to describe the content of a page. Okay, HTTP supports a number of methods. Basically, we are interested in only the first 5, let's say -1. Head is not that useful for us, I mean just for completeness. And we will see them in more details later today. Okay. You probably know very well the get, that is also the one that you saw in the slides. Okay, get is the simplest one. Just give me the content that correspond to this URL, so slash something on a server, okay? Okay, and then there's the web server that serves content, typically pages in older, in traditional web applications, or files and so on, and in more modern applications, typically it answers URLs that correspond to APIs. APIs means URLs that if requested, if sent in the request, will perform specific actions on the server, and they will return some content. Okay. So, in short, the web server is just a piece of software that is able to understand the HTTP protocol, and depending on what was programmed to do, it can understand a certain number of URLs coming with the request, and it can answer with, depending on the URL and the format and whatever we instructed to do, whatever we told the server to do, it can answer with, as we said, just static content, taken from files in the server, or create content, create data, retrieve data, and pass data back to the client. Okay. Logically, at the logical level, it's like there's just one HTTP connection for each request. So we send a request, we open an HTTP channel, we send a request, and we get the information back. Okay. That's just logical because recent versions of HTTP improved this a little bit, because there's quite an overhead in opening, HTTP connections each time, and the underlying TCP connection and so on. Typically, it's a multi-process, multi-threaded software. That means it can handle multiple clients at the same time. Okay. This is really, really, really important. Don't forget this, because it's true that we are trying to design a web application, and so basically we are trying to make a web application work for our purposes, and we are the only user when we are developing the application. What you need to keep in mind that there might be multiple users, and this thing will be checked carefully at the exam. Okay, I mean, I don't mean I will open 3 clients, but I will check that you wrote the software in a reasonable way that can handle multiple clients simultaneously at the same time. Okay, because that's the whole point of web application. We have only one server and we have multiple clients. So the only server that you have must be able to handle everybody all together if necessary, at the same time if necessary. Okay, these are just statistics. I mean, just updated a few days ago. Basically, every month they publish a new graph. I mean, but just for for your general knowledge. I mean, there was a software very much used in the past for implementing web servers, and nowadays the situation is quite differentiated. I mean, there's quite a number of different softwares used today. Okay, you also need to differentiate between all sites and active sites. I mean, the ones that are mostly used. I mean, you can open a server and leave it for years and nobody asks anything. Okay, it's fine, but I mean, maybe it's not that useful to consider it as an active website, and so think about which software has been used and so on. It's been mostly forgot. Okay, so in our course, of course, we need a web server, and we will adopt a web server that runs inside the Node.js environment just for our convenience. Okay, because it allows us to write the server code in JavaScript, so we don't have to learn another language. As I already told you, I mean, we could use any other language, because I mean, the interface between server and client is just the HTTP protocol. So as long as we produce something that can be understood on one side and the other, it's fine. So we could use PHP, we could use Java, we could use even Python, whatever you want. I mean, but in this case, for this course, please, I mean, you need to pass the exam, you need to write a server in Node.js with the library Express and in JavaScript, of course. And why we are using a library? Because, of course, implementing a protocol from scratch is useless from our point of view, but also prone to errors, and it's a waste of time. I mean, it can be done once for for everybody. Okay, and so we use a library, a package actually, which is called Express, that is really simple to use, and it helps us a lot in designing, in writing the code for the web server. And very important, this is just a choice for our course. Again, don't don't think that every server is wrote in Node.js with Express. Actually, there are some implementations around also from big companies that maybe for some purposes uses this approach. Okay, made it a bit more robust, but in general, typically the web server is not written in Node plus Express. Okay, but since it's so convenient for us, we just have a quick way to install packages and npm install and so on, and that's this good library, etc. We use this approach. Okay, and then there's a database, and again we will use an SQL database. We know that other approaches exist, like the no SQL approaches, okay, where data is less structured. It's not structured in tables, but again, we ask you to stick to this decision, just because it's easier to debug and to check at the exam again. Okay, there's no real strict need for this in general. So when you are programming a web application in general, you can use the approach that you think it suits best your case. But just for this course, use standard SQL and a standard SQL database, and we will use again another package, the one that you already used in the lab, that is SQLite for storing the information. Again, we need something simple. The course is just 8 credits, not 20. Okay, so we need to have something which is compact enough for being explained and used, and also for the exam. Okay, so given this, how to say, the status of the overview of the web applications, now we go into more details about what we can do nowadays for web applications. So we talk about architectural patterns. So what is done today, what is being done today for designing web applications? Well, first we start from the history. The traditional architectural pattern was that you interact with the browser decides to make a new request to the server, and the server answers with new content to be displayed in the browser. Okay, so the browser basically had only the requirement to display content, so interpret the language that was used on the server to create a new view, a new page to be shown. Okay, with some additional content like images, like styling and so on, etc. I don't want to say it's very basic, but it can be complex. But basically there is a new view, a new page created on the server every time you interact with the client and you ask to send information, a request to the server. Okay. At a certain point, somebody realized, well, this is really a very basic way of interacting. Every time I do something, I send a request, and everything has to be recreated from scratch. And also think that like 20 years ago or more, the browsers, computers, and so on were not so powerful. So this way of interacting means that you need to wait for the user interface to be redrawn, a new page to be loaded, and the network connection not that fast, and so on. So people started thinking how to improve on this. Okay, and at a certain point, they realized that part of the pages could have been dynamically updated with some asynchronous request by the browser. And so basically in the browser, there were some APIs, in terms of functions, JavaScript function that could be called by JavaScript code that told the browser, well, if this happens, this event happens, like a click or whatever, you go to the server and you load this information. So you send an HTTP request to the server, and the server sends you back some information. Can be a piece of content to be displayed in the page, can be raw information, and so on. And so you don't have to reload the whole page. okay? And so the interaction was made faster, okay? Actually, by the way, this way of interacting with the server, you're quite young, but I mean, was introduced, I think, firstly by Google when you typed, you typed in the search box. Every time you typed, you sent an asynchronous request, and they were so fast that they could provide you suggestions, okay? And that basically made this way of designing web application very popular. I mean, it was not like forbidden. I mean, it was difficult to program before until basically everybody understood that it was a possible thing that worked so well, so everybody started to use this kind of approach, okay? So the traditional architectural pattern is that web application does the rendering on the server side. So every time you send a request, you make a new view, a new page, you send it back to the client, and if you want to improve this a little bit with the so-called rich client approach, sometimes you don't send the whole page but just part of it, partial information, so you don't have to reload everything. Okay, so this is a picture of all the layers at work, so exactly the same diagram as before, but here you can see this data request and data response, where you can send asynchronous requests without reloading the whole page. So you're not just sending back the whole page in HTML and so on, but you can have these answers containing just data or data plus some pieces of user interface code. Okay, and you see that the diagram is quite complex. Here you also see the database server. Okay. It's one more piece, but in general it's quite complex because you have a normal way of interacting with the server that allows you to load new pages, and plus you have this asynchronous way to interact with the server. Okay, so let's come to modern days. Well, since a few years, applications have started to be designed in a different way. Okay, following this single page application approach, that is the way in which we will design our application in this course. So basically, the server only sends the first time the exact same page, so the starting page for your URL, and everything else is done by code, JavaScript code, running in the client side that basically can modify the appearance of the page. So can create objects and things that can be shown. It handles the interaction with the user, and it can make new requests toward the server. And when you make this request, you will only ask for data to be shown, and the JavaScript code on the client will take care of showing them correctly to the user, okay? And constructing parts of the interface if needed, etc. Okay? So in short, there's a single web server typically that for a specific URL, it gives you the initial page with the code, with the JavaScript code. And then there are other URLs where you can ask for the data, or you can send data that makes your application work. Okay, so like you populate a list, and then I think in the lab you have a list of films, and you want to add a new film, so you have another URL to add the film, you have another one to update the content, title and properties of the film, etc. Okay, that's a modern way of designing the application. Here, logically, they are two different web servers. I mean, one is very simple, just meant to give you the initial code and page for displaying something when you arrive on the website. And then there's another server, logical server, which only provides information. So it talks in terms of application level information. So like the list of films, what you want to add, etc. And it takes care of doing all the operation required by the application, retrieving information from the database, storing information, etc. Okay. In practice, well, for our course, actually, there will be two different web servers. But I mean, in practice, you can implement everything on the same web server. Okay, you just differentiate what is given back to the client for different URLs. Okay, so typically the basic URL, the slash, okay, gives you the initial page because it's the top level domain. How it's called, the host name plus the domain, etc., that you use to navigate on that site. And when you add some other information to the URL, you look for URLs that allows you to perform the operation. Okay, so this logical server that provides the raw information. So we are moving from the left situation to the right situation. So in the traditional approach, we have this, of course, the browser user interface always the same. And here you add JavaScript. You already had JavaScript because you could do this asynchronous request. But JavaScript was not meant to, take care of the whole user interface. It was just meant to interact asynchronously with the web server when there was something to do and was designed by the developer to interact asynchronously for this operation. And on the server side, basically you had the web server that took part you had the web server where whose task was to create the pages also. Okay, depending on where you are. You are on the initial page, you were logged in, you were seeing the list of items that you need to purchase or whatever. Okay, so there's some logic on the web server that decides what to show in the interface. And then, of course, there's some business services, data, and so on. So basically, where you access the information, you take the information from the database server, and you pass this information to the web server so that it can decide how to construct the page, how to construct the view. Okay. In the modern single-page application approach, basically, we only exchange information. So this data that for our cause will be JSON encoded or using this format, JSON. Okay, and this SPA engine will be a quite complex JavaScript code. Okay, and that's why we need a library like React to help us write, code in a more efficient way. And it will take care of creating the views and the interface that at any time is needed by the user to interact with our application. Okay, and so basically, moving from the left to the right, we don't have to design the web server logic anymore, but we need to design API endpoints. Okay. While before, they were just simple URLs that could correspond, for instance, to pages, different views in your application. Here, you design API endpoints that basically correspond to way to retrieve or store or modify data on the server. Okay? That's really the big difference between the two cases. Okay? And why this approach is nowadays so common? Because it has quite a number of advantages, like it doesn't require you to reload the page. Reloading the page is a slow operation, okay, in general. It takes the browser quite a lot of time to do it. Modern browsers are more efficient, but in general, there's a lot of operations to do. You are also resetting the memory of the browser for that page because you load another page, okay? And also, you don't make the user wait too much. Of course, we are less and less patient waiting, for applications to work as we expect. We request information, we would like to see the information immediately and so on, without waiting too much. And this kind of approach allows you to perform all the operations that can be done on the client side directly on the client side. If there's no need to interact with the server, that's fine. We can immediately update the content. And so that's the fastest possible way of updating the user interface. And if there's a need to interact with the server, with the remote endpoint, of course, we need to wait for the answer. But in the meanwhile, we can do something on the client side as well, because the JavaScript code and the place where the user interface is controlled is running on our device, okay, on the client device. So it can run immediately, okay? And there's plenty of applications designed in this way, okay? Well, I would say most of the applications that you find nowadays, but I mean, the very easy to understand application that uses this approach can be, for instance, Google Doc. Okay, probably everyone has used the Google Doc. I mean, open a text editor in the browser. Can be Google Doc, Microsoft Word, whatever, you know, text editor, web-based text editor. I mean, we don't really care. I mean, but the fact is that everything is run on the client, and the only thing that you do when you type and interact with the application is that sometimes you need to do requests towards the server, and the server basically will store what you are doing, like what you are typing, or if it's in a spreadsheet, the formulas that you are inserting. Sometimes it will help you to perform some computation, but depending on how the application has been designed, most of the operation will be performed on the client side because we don't want to have page reloading and no extra waiting time. That's exactly what happened in traditional application. I mean, not web application, but application. Application running locally in the computer respond immediately because the code is running locally. And we're trying to emulate the same behavior in the browser. Okay? Since nowadays the browser is quite powerful and we have a quite powerful language like JavaScript. Okay, of course there are also disadvantages to this approach. I mean that nothing comes for free. And for instance, search engine optimization is difficult to perform. I mean, if you think in terms of the Google web crawler that goes around and indexes websites, you ask for your website, and it gives you an empty website. I mean, just the basic, because the rest is filled up with by JavaScript. But the web crawler cannot run JavaScript. It's not a browser. Okay, so it sees an empty page. So indexing content can become difficult. Okay, of course, the people have thought solutions for these problems and so on, and also people like Google and other search engines have tried to introduce modalities in which they don't see an empty page because that's not what the user is seeing. Okay, but I mean there are difficulties that need to be addressed. Another important thing is that the browser history is not working anymore because you just have one single page, so there's no place where you can go. I mean, you can go back, but it means it was the previous website, another application, another place. Okay, but you are quite used. I mean, maybe you in particular not because you are quite skilled with computers, but normal users of computers are quite used to press, back and forward to move in the views of the application. So that's not that convenient. I mean, browser history is not working, and we will see a way to address this problem. I mean, at least in principle. And then if the application is well designed, typically you shouldn't use the back and forward button. At the exam, we will not use those buttons, okay? Because typically, if the application is well designed, there should be some place in the user interface where you can click to return to the previous case, to the previous view, and so on, if needed. I mean, okay? Like log in, log out, or see the list, or back home, and so on. There should be links, button, something that helps you to navigate through your web application. Okay? And also there are some security issues to consider because you are performing computation on the client side. And the client side can be inspected by the user. Okay? If the user is malicious, you should consider this case. Okay? While if the computation is performed on the remote computer, on the web server, I mean, you cannot really see nothing. I mean, you cannot see the code because the code runs on the server, it's not transferred to the client, and you cannot see the status inside the code, the value of the variables, etc. While if everything is running in the client, we already saw that you can inspect what's happening. I mean, actually, it comes with any browser. That's the developer tools where you can see what's happening inside the code in the page. Okay, so we need to be quite careful about what we are performing on the client side and on the server side. And this is a very, 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 very important aspect. Okay, also for the exam, we will carefully check that things that need to be done on the server side are done on the server side. Okay, you are from the cybersecurity course of study, and so it's really, really important for this course to, to make sure that operations that should be protected are not performed in a way that can be tampered by the client, by the user. Okay, so basically it means they need to be performed on the server side. Okay, so that's a really important skill to learn in this course. Okay, there are operations that need to be performed in a secure way, and so they need to be moved on the server side, regardless of the architectural pattern, whatever, single page application and so on. You need to put them in a secure place, and the only secure place is the server. Okay, okay, and then client-side rendering can be slow. I mean, today it depends. Okay, if you really have a lot of JavaScript code and this code is written really badly, probably yes. But I mean, with this React library and with reasonably good code and so on, this problem can be limited. Okay. Okay. Actually, there are also two other patterns which are starting to become more common, but I mean, we will not go into details on this. Okay, isomorphic application. That's basically a combination of single-page application. That is what we are going to learn here, with some server-side rendering, just to speed up things. Okay, but there are a mixture of the operation of rendering between the server and the client, so they are more complex than single-page application. And this is a basic course about web applications, so we don't want to go into so many details about how to design an application where the rendering is split between the client and the server. Okay, of course we can optimize things and make things faster, but it's also more difficult. And then there's this progressive web application that looks more or less like native applications. Okay, I mean, the problem of web applications is that they run into inside the browser, so they have all the limitations of the web pages that are inside the browser. I mean, they cannot access a local file system, for instance. It's forbidden because I mean, it's just code that you download from the network. I mean, it's a huge security risk allowing the code, to have a look at what's on your computer. Okay, so the browser doesn't allow any JavaScript code to look through the files that you have on your computer, for instance. And there are other limitations. But since web applications are becoming the standard way of programming applications in general, it would be nice if this programming pattern could be used also for emulating traditional web applications, and that's a possibility. Okay, this progressive web application that emulate native application. But again, we are not going into details here because of lack of time, and also because to address these two other approaches, we in any case need to understand something about single page application. Okay, so last thing of this storytelling, let's say, about a web application is note that when we design the server in this way with APIs, so URLs that performs operation on data, we can easily recycle the application server for multiple client cases. So you have the traditional application on the client, on the PC, on the laptop, and so on, running in a browser. That's fine. But you can reuse the same APIs also for native mobile application. You're writing a mobile application. That means an app for your mobile phone. At a certain time, this app needs to query for information, ask for information to a server. I mean, the APIs can be the same. There's no reason where you should need a different set of APIs if the operation and what you need to perform is exactly the same. Okay, so this way of proceeding is not just good for the user, but it can also be good for designing a system where the web application is part of a more complex environment, where you don't only have the client application running in a browser, but you can have different clients, like native applications for mobile environment. Okay. Okay, so that's more or less all. I mean, the only thing I want to mention here, that's from Wikipedia. I mean, we don't really like showing so many links from Wikipedia because, I mean, everybody can write stuff there and nobody checks. But, I mean, sometimes it's useful just to give you a rough idea. Like, you see the most popular websites, where actually I don't know two of them. And in any case, it doesn't matter. The only thing I would like to mention here is that, you see, on the front-end side, basically everybody is using JavaScript. Why? Because that's the only programming language that we can use in the browser. The browser only understands JavaScript. But you see the variety of stuff that you have on the backend, provided that this is reliable. I mean, they are private companies with industrial secrets and stuff, but I mean, sometimes you know these things and people know these things. I mean, it's not really a big secret. I mean, just to know which language is used on the server side, also for Google, Facebook, etc. But you see that there are quite a number of languages that can be used on the server side. Okay, and they change over time, of course. There are plenty of developers, so sometimes they optimize things, they change things, and so on. I think Facebook started, if I'm not wrong, it started with PHP and then optimized it and then changed to something else and so on. Okay, and depending on the functionality they are implementing, they can also use different languages. Okay, so I mean, the important thing is that we understand we are decoupling the client from the server. That's the HTTP protocol in the middle, and we design APIs that is exactly what we are going to do today and in the next lecture, because that's the basic point from which we can start the development. Okay, writing the server will be quite easy in the sense that, I mean, it means that APIs basically go to the database, they query for information or they store information, more or less. They will do a few additional checks depending on the application, but that's all. And then we will focus on the client, how to update the interface, where to put the information once we load them, and so on. Okay, so if you have any questions, we are welcome to ask. Otherwise, we proceed with saying a few words about Express. Express is the package that we are going to use for the server. Okay, so the goal here is implemented a very simple web server, but fully functional in the sense that it can be used, to make our web application work. We cannot just design a web application without thinking about the server side. Okay, that would be half of the work. Okay, so well, that's just a recap of HTTP. We already saw it. I mean, let's go into the details that are useful for us, for our web applications. Okay, so HTTP message have an initial line. You remember GET or HTTP OK, request response. So that's the first initial line, just one line. That means a set of characters, text characters with a new line. Okay, and then there are headers, as you saw here. Quite a number of headers depending on the software that you use to make a request and response. There's an empty blank line, CRLF, so there are two characters to make the new line short. And then there's the body, and you see the dashed line. It means it can be optional depending on what we are going to do. Okay, so request has three parts. That's a method, very, very important. You need to decide the correct method for each API you're going to write. That's the first thing we check at the exam. We don't open with the application. I mean, we just make the application starts. Okay, make sure the application starts. And then we will have a look at the README where you specified which are your APIs. And looking at the methods and the URL, because the APIs basically define how the client and the server speak together, talk together. And from that, you can understand a lot about how the applications are designed. Think about me or my colleague Antonio needs to evaluate your submission. We know nothing about what you decided to do for the application. So first of all, we think in terms of which information is coming back and forth from the client to the server and vice versa. And how do we get an idea quickly about this? Looking at the API. So looking at the methods, at the URLs that you used for designing your APIs. Okay, so the point that can be contacted on the web server to ask for information or to store and send information. So first point is, first element is the method. And then there's a path, local path. That means there's no host name here. Okay, just the local path, /API /something, /courses, shopping cart, whatever you want, depending on the application. And then there's the protocol version, but that's inserted automatically. The rest, everything will be inserted automatically by the library, but the name of the URL and the method we would like to use are decided by our code, okay? And then, of course, the implementation of the protocol is up to the library, but which method we are going to use and which URL we are going to contact is decided by us, the developer of the application. So it's important to know, and indeed it's the first thing it's sent to the server. Then there are headers, later. Okay, let's stop on the methods first. Let's stay on the method. So get, post, put, delete, the ones that you saw before, okay? Only 4. We don't expect to see more than these 4. Some people like patch at the exam, it's fine, but it's not really strictly required, okay? Just a matter of semantic, doesn't really matter for the exam. Get, post, put, delete. Why head is here? Well, actually head is like a short version of get, but it's not really needed in our application because we typically want to load information and we never ask if the information didn't change or not unless, there is really specific reason, but I didn't see it in the anybody using head in the last years or so. I think, we could even remove it from the slides maybe, just for completeness. We leave it here. So get request a representation of the specified resource. So depending on the URL, it should only retrieve data, do nothing else. Okay, just probably querying the database, whatever is needed, and it gives you some data. Post, submit something to the specified resource, so to the specified URL, often, mostly always, causing a change in the state of the server or some side effect in the server. So it's stored in the database something, it changes the status of the database, okay? It's not just we are reading content in the database, we are changing, we are adding something in the database, we are modifying something in the database. Put, replace the current representation of target resources. So we update something that is typically already existing. And delete, of course, we delete some information, okay? The resource in general. Okay, response. Well, the first line is a status line, 3 parts, the protocol version, a status code, and a human readable translation of the status code. Okay, these are the 2 most common ones. 200, okay. Everything went fine on the server side, and the server says okay. Or there's been a problem, and there can be quite a number of problems. You see, this is not an exhaustive list, but just to give you an idea. By the way, the status codes are also, separated by categories, depending on the first number of the status code, the first digit, actually. Typically in the 200 series, you have everything successful, like okay, or you send something that has been created, accepted, whatever. Redirect, I mean, typically in our application we don't use it. Client error, we send something that cannot be interpreted, for instance. Okay, some unprocessable entity, for instance. It's a typical error that we can have, I mean, in our examples, I mean. Or some server error. Like, I mean, typically 500, internal server error. No idea what happened. I mean, I cannot answer your request, and sorry, okay? Maybe there's a bug in the code, the code crashed. The code, I mean, that handled that request crashed. Maybe you were not able to connect to the database and so on. It would be nice if there's some additional information, especially when you are debugging the application, to understand what's happening. But I mean, in general, there can be a lot of things that can be wrong on the server, and if you have no other idea what to say, you can just say internal server error. That's also the response that you get if the code crashes. I mean, the library Express will simply send back, you know, the internal server error because, I mean, it got the fact that the code crashed, and luckily the whole web server didn't crash, and so it has to give an answer to the request. It will give this one, okay? And then we have header lines. Basically, one line per header. They are specified in the HTTP protocol. There are 46 headers. We don't really care. We only care that there's one mandatory header in all requests. We are talking about request here, just request. That's the host name, because HTTP 1.1 allows you to make you know, request to the same IP address, so on the same HTTP, on the same TCP connection for different hosts. Okay, so you can host on the same IP address different hosts. So when you make an HTTP request, you need to say mandatorily, compulsory. You need to say which host you would like to talk to. Okay. In our case, it will be only us because it's just us. So this host will be actually on our computer just for convenience, and so it will be localhost. Okay, but just for convenience, it can be anywhere in the network. Okay, but since you know, programming distributed code is already difficult without involving the fact that we have a remote computer and so on, we keep the remote server actually on the same computer where we have the client as well. Okay, but it should be always possible to move this code on another server. Of course, just changing the host name, and everything should work. Okay, we are designing distributed application where the server and the client stays in different places. Okay, we are not putting the server in another place like the cloud, whatever you want to put them, because I mean, it's more convenient if you have everything on our computer, right? We don't have to have the network connection, and we don't have to wait for the transfers on the network, and it's easier to edit and change files on the local computer rather than on a remote computer, right? And debugging and all this stuff. Okay, good. Message body, that's the last part. It's the data sent after the header lines, after this empty blank line. And basically, can be anything. Can be HTML code, so a description of the page for the first request, or can be JSON data, as we say. Any kind of data, even binary data. We can transfer images, for instance, videos, whatever we want. Okay. In case, I mean, not in case, but it's better to have a content type header in the response, okay, and in the request as well if we have a body that indicates which is the format of the data that is put into the body. Okay, so when you get something back from the server, the browser and your JavaScript code will check this content type header to see which is the format of the data that we are going to read in the body. Okay? So if it's HTML, we can parse it with the HTML parser. If it's JSON, we can parse it with the JSON parser. If it's an image or whatever, we can pass it, to the handler of that format and display it accordingly. Okay? Okay, there can be compression, but it's not, we don't really care. The only thing we will see in our course is just this text HTML as the response, or application JSON, which is the MIME type for JSON. So that's standard from the RFC. That's the name, application/JSON. Both for the response and for the request when we are going to send information from the client to the server. Because also the server needs to know which is the format of the body when it receives a request. Okay, so that's a summary of the various HTTP methods. Get has no request body. Okay? So there's nothing we can send in the body. The library implementing HTTP in the browser, when we ask to perform a GET request from JavaScript, not accepting anything for the body. But it expects something in the response. Of course, otherwise, there's nothing to show, nothing to handle. Okay, the head is just to check if the content is present or not, so just ignore it. Post, of course, it expects something in the body because it's meant to send information to the server. So it's better that we send something, right? Otherwise, there's nothing that the server can handle. And the response may be present or not. Okay? Typically, it's present. Typically, it says some additional information about the outcome of the operation. Like I created a new object. That's the new object. That's the new ID of the object. Whatever you might need. Put yes, because you need to send something to the server to update some information. And again, the answer is like a post. It depends on your implementation and what you wanted to do. Okay? And delete, well, delete both body in the request and body in the response are optional. Okay? Because what you wrote in the initial line here, in the URL, might be enough. Delete the item number 45. 45 might be enough. Okay? So there's nothing else to send. And there's nothing else to know. Remember that we have in the initial line a status code. If the answer is OK, it has been deleted. If the answer was error, internal server error and so on, probably something went wrong and you should take care of the error on the client side and decide what to do. Send the request again or whatever. Okay? Note this column. This column is really important. Is the method idempotent or not? What does idempotent mean? Idempotent means I send the same request again and the status of the server will be the same. Okay? Of course, the get is idempotent by definition. It's just reading stuff. We are not modifying anything. So, of course, the status of the server doesn't change. Change because of our request. Of course, it's a multi-client application. Something can be changed by others. Yeah, that's fine. But idempotent refers to our request. We send 2 requests and nothing else happened in the meanwhile. We get the same response. Okay? Otherwise, the get should not be used as a method for the request. It's probably another method. You are doing another operation on the server. You're not just reading. You are doing something else. Okay? As, for instance, in the post, which is by definition not idempotent. Post is typically used to create information and store information in the server. So like, create a new course, create a new, add a new item in the basket, in the shopping cart. Okay? If you perform it twice, you add twice 2 items. Okay? You add maybe the same item, but twice. Okay? So every time you send a request, that's a modification on the server. So you need to know if the method is idempotent or not, because you need to know that performing the same request again is let's say, dangerous, or in a certain sense we can say it doesn't give you the same result. If there's something that doesn't work in the first request, you need to be careful, because maybe you just didn't get the result, or there's been a problem of communication and so on. And so you need to be very careful before sending another request which is exactly the same, because this might trigger a change in the server that is not wanted. Okay? While for put and delete, the request is idempotent, because if they are written correctly, they have been written correctly, you ask for updating certain information with a certain value, and if you perform it twice, you're just overwriting the already updated information, but the result, the final result is exactly the same. It's like with the delete. I mean, you delete some information. The second time, it's true that you will not find the information, but the final result is exactly the same. It didn't exist before. It didn't exist. It doesn't exist now. Okay? You sent a delete for something that was already deleted, but the final result is the item is in any case deleted. Okay? So that's idempotent. So in short, we can say, the only method which is not idempotent is post. So also for the exam, you need to be very, very careful. When you do operation that modify the status of the server, you need to use post. We will check for sure. I am sure I check for everybody, for every method, if it has to be a post or not. Okay? And then we can discuss if it's a put or post, depending on how you do the update and so on. But you need to be really careful that there are cases where post cannot be avoided. Okay? It's an error. Okay? That's also why, in traditional web applications, sometimes also in modern web applications, when you reload a page, okay, that had an URL that was submitted, you navigate to a page that performed a request with the post to the server, the browser typically says, are you really sure that you want to send this request again? Because it's a post request. It's not idempotent. If the request was pay 100 euros to somebody and you send it again, you pay again. Okay? In principle. Of course, in practice, these things are checked quite carefully on the web server. But let's say just you want to add one thing to the shopping cart. If you send it again, you find two things in the shopping cart. Okay? And that's why the browser says, are you really sure? Because the meaning of the post method is, we are going to modify the server. Be careful. Okay? If you perform the action with the get, you will not get this warning from the browser. Okay? But it's wrong to do a modification with the get because of the meaning of the HTTP method. And also, it carries some consequences, like, for instance, the browser cannot warn you about what you're going to do. Okay? Because it expects that nothing changes, so it's just a get. Okay? So it's really, really important. Okay? We are going to do this request asynchronously through our code. So actually, the browser will not warn us in any case. But that's the origin. That's why there were different methods defined in HTTP, because they have a different semantic meaning. Okay? And if you stick to this semantic, it's better, because also when you read the code, you know that what the method is supposed to do. Okay? And what are the consequences of using this method or these APIs and so on. Okay? So it's a long story, I know, but it's a major source of problems at the exam. So pay a lot of attention to this aspect. Use the correct HTTP method when designing the APIs. Okay? Because it's one of the things we will check for sure. Express. So brief recap of HTTP, and now we'll see how to implement it with Express, this package. Actually, no, there's already a package that is named HTTP. You don't have to install, import it, and so on, but I mean, it's really basic. So we are going to install this package Express, which is quite easy to use instead. I mean, it's really friendly, different from HTTP. And it's really easy to perform this operation. I mean, npm install, and then it's a program like any other program in JavaScript. We already know how to run a program, right? So we just run it from the command line, node with the name of the JavaScript program. That's all, okay? It will not stop. It's a server, right? When you run a server, the server is there listening for requests, and it will not stop autonomously. It's a server. It's like the waiter at the restaurant. It will not go away until you go away, right? So it's a waiter. It waits for requests. So you need to close it explicitly with some other methods, which are not included in the APIs and so on, okay? So, like, you have the terminal, you press Ctrl-C, and then you can stop the application. So stop the server, okay? So it's an external way that stops the server. It's the system administrator that stops the server, that runs the server in the beginning, or it runs automatically when the computer starts, it depends, okay? Or it may happen the application server crashes. Hopefully not your exam, not with your code, okay? Because, yeah, okay, we can restart it, but the server is not supposed to crash, right? So it's an error, and probably there will be some points deducted somewhere, okay? So we should do everything, any possible, use any possible mean to avoid that the server crashes. Express is very well written. It's not like, I mean, you really need to do something bad, I mean, to make it crash, okay? But it's not just because you don't find something in the database that the server crashes and so on, or because you cannot open the database, etc. I mean, you really need to have something wrong in your programming, okay, to make the server crash. And in general, also there can be external mechanisms to make sure that the server is restarted when it crashes and so on, but it is outside the scope of this course. From our point of view, we have another problem, that we are developing the server. Okay, so we start from a very simple server, and we will add new code. And the point is that every time you add new code, you are modifying the program, and since the program doesn't stop by itself, it's not like, print something and that's end. You need to stop and restart the program to read the new program, okay? And so just for our convenience, there's this really useful package nodemon that you can install, again, with npm. And basically, it will monitor if any file changes. And if any file changes, because we saved it with the Visual Studio Code, whatever, it will restart the server automatically. Because one of the most common problems we have when we develop the server is that we do a modification, we save, and we forget to restart the server, okay? And then things don't work, and you don't know why. I mean, and the reason is very simple. You forgot to restart the server. You're still running the old server, okay? Only for this course, only for nodemon, you can install this package globally. There's an option, -G, that means global, okay? But just for this package, because it's very convenient, because you will use it in every project, okay? So, I mean, you can also install it without the -G, but you need to install it for all projects. It's fine. I mean, it's not that big. But remember that only for this package you use -G, because if you use for some other packages, then you submit a project at the exam, and you submit a package JSON with all the dependency list, and we will miss something. We start from scratch. It's nothing. So we need to have Express, we need to have SQLite 3, and all this stuff, and everything needs to be present. Okay? But nodemon is just for development, so it's just for you. We can run the the project with Node, without Nodemon at the exam, because we are not supposed to restart the server. Okay? Yeah, first steps. Let's see the example. Yeah, and then I think maybe we can break. Then otherwise it starts to be long. Let me see if the example works. So we already have some code on the Git. Remember the schedule. That's an example that takes you to, WA weeks, that lecture material. And we have this QA server, version 1, QA question and answer, because we will develop an example of a web application during the lectures. Okay, and we have quite a number of files. This is a really first example. Okay, let's try to run it in the Visual Studio Code. Okay, oops, code actually. Let me see, QA server, yes. So first example slide. Okay, so week 03. QA server. Node, I don't think I have, no, I have Nodemon, I think. Well, let's start with Node, and then later we can use Nodemon. Node, first example. Okay. Okay, of course, I forgot to install Express. Okay. So I hope it's listed, yes. Okay, so npm c. Okay. npm c, so clean install. Okay, server is ready. And you see, it doesn't stop. It's a server. Okay? Server ready, and what's the code? Code is just listening on a port, TCP port, number 3000. And there's just one HTTP URL defined. Okay? We can try to contact the server. Okay? Localhost 3000. Okay? That was my colleague. It was last year, I think. Hello, Antonio. Okay? So that's an answer and really basic stuff. I mean, let's try to see what happened. That's the way in which we will use the browser at the exam. Always with the debugging and developer tools open. Okay? Because we want to see the exchanges between client and server. So, yeah, just reload. And you see, well, it's a long story because it's not 200, but it's like 200, okay? I know, maybe we can disable cache, yes. Let's make it easy. Yeah, 200, okay. And that's a request, add a request, okay? So that's the first get HTTP localhost slash, but localhost, there's no row. Where is the row? No, okay, well, you cannot see it row here, and it doesn't matter. And there are the request header. We don't really care about the request header. I mean, there's quite a lot of stuff. We can see the request body here in this tab. No payload, no body. It's a get, right? There's no body. But we can see the response. And the response was hello, Antonio. Okay, just a few bytes. And we can see the headers and the response headers as well. And you can see the content type. Well, actually text HTML, because that's the default for Express. Actually, the browser is so smart, let's say, that it can interpret stuff which is also not HTML. It's very simple, like, it doesn't know what to do. It just shows something, okay? It just text, it just shows this text, okay? And that's basically the easiest request that you can make with the browser, and the simplest server that you can write with Express. Okay, let's just see the slide about you know, the first step, and then we will stop for the break. Okay. So we import the package. As we do with most of the packages, we create an object that is the one returned by calling the variable that has the handle to the package. And then we define a route / we attach a callback. So some code that will be executed when we get a request in terms of get as HTTP method and then / as the URL. And then we start the server. Okay, that's a basic, the simplest thing you can do. App listen on a certain port, and there is also a callback, a nice callback that it's called when the server has started. Okay, this is JavaScript. When we want to know that an asynchronous operation has been performed, like starting a server, you give a callback, right? And in this case, we just print on the terminal. Okay. So we just tested this code, and then next we will see how Express works. Okay, so just a few things to make you start with the web server. Okay, I think we can break, right? It's 2:30, 10 minutes break or something like this. And in case you have any questions or comments or issues, please come here. Otherwise, we will see later for next part.